Hey guys, greetings from beautiful New Hope, Pennsylvania. Sitting in my mom's art studio right now, recording this. Always nice to be able to combine business with pleasure. I am going to send out the updated syllabus at the same time I send out the link for this class. I'm going to do one email. So, check your email for the link to the updated syllabus. It will reflect that we have video classes on Thursday, today, and Tuesday, and it will also reflect the new date for the midterm. And with that, I'll just get right into it. When we were together last time, I talked about operationalization, which is when you move from an abstract concept to something you can measure. And we talked about operationalizing plant growth. And I hope that you took away a couple lessons from that discussion. One is that we can very rarely prove things beyond a shadow of a doubt because we can very rarely capture completely the concepts that we care about in things that we can measure. So we talked about the different ways to measure plant growth, and we thought even at the end of that, we hadn't fully captured the complex thing that is what we mean by plant growth, right? And plant growth is relatively easy to measure. When we think about things like unemployment or, urban renewal, those things are sort of abstract by their definition. To claim that we have a full measure of those things is probably incorrect. But the second thing I wanted you to take out of that was that if we pay careful attention to our variables, we can reduce the gap between the concept that we care about and the measures that we use to measure it, and bring pretty powerful evidence that can suggest something. We may even be able to suggest something beyond a reasonable doubt. If you think about the weather forecasting that we read about earlier in the semester, if you hear that there's a 100% chance of rain, you can bet that the meteorologists are pretty darn sure that it's rain. And you can say that, yeah, they've proven it's going to rain tomorrow. I want to back away from that word prove again because, right, it could always be 100% chance of rain. I feel like there have been instances where it has been called for 100% chance of rain and it hasn't happened. But, most of the time, it suggests beyond a reasonable doubt that it's going to rain tomorrow. So, avoid prove, but we can bring a lot of evidence that suggests some pretty powerful things and some pretty definitive things. How do you do operational definition? The big thing that we talked about, or how do you do operationalization? The big thing we talked about was an operational definition. That is, before you start your project, you write down everything that will count as confirmation for your hypothesis. So, if I'm going to measure the unemployment rate, I need a operationalization of what it means to be employed. I list all the categories that I say a person could be in and count as employed for my study. Everything that you don't list in your operational definition doesn't count. It's not evidence in support of your hypothesis. We do this for a couple reasons. It helps you think about your topic beforehand and develop a more robust theoretical understanding of the concept you're trying to measure. It also lets other people see your operationalization in case they want to do it a different way. And that's really important because, think again in economics, we could go to probably the top 10 organizations in the world that try to measure economic growth. Places like the UN, places like the OECD in Europe. I bet you they have different, maybe with a lot of overlap, but different indicators of what it means to have economic growth in a country. Smart people, even the smartest people, will disagree, right? That's the enduring lesson of the Lakoff piece we read at the beginning of the semester. And when we write out our operational definition and share it with the world, if they do disagree about the relative importance of something, let them go off and do their own study. Also talked about 3 levels of management. There's nominal measurement, which is yes or no, on or off, black or white. The most basic type of measurement, oftentimes not the most appropriate level of measurement that we could have in the social sciences. There's also ordinal, which is categorical. So remember the 7-point scale that we use in political science to measure partisanship. Sometimes, like with partisanship that is not a tangible thing, this is the best that we can do. And ordinal, you will see a lot of categorical, a lot of ordinal measurements in any social science article that you read that uses quantitative analysis. It's some phenomenon that we are intangible, but we still want to bring statistical analysis to. We go with ordinal measures. But the best level of measurement at all is interval, raw numbers, raw data. Donald Trump made $1.31 billion last year. There are 3 pens on the table sitting next to me. We like this level of measurement because it represents something real, it represents something tangible, as opposed to the other 2 where we're sort of, placing things into fairly arbitrary categories. And it also provides the most possible information of any of the 3 levels. And that brings up an important point that I realized in a conversation yesterday, or the last class. I care less that you know the names of these specific variables. What I care most about is particularly because I've already had one conversations with Ashley in the 12 o'clock class that indicates that other disciplines that you guys might have taken methods classes on call variables and call the ways that you operationalize and call the levels of measurement something different. So I'm pledging right now, I'm not going to ask you on a quiz or a test, what is nominal measurement, what is ordinal measurement, what is interval measurement. Like I'm not interested that you know vocabulary words. What I'm very interested that you learn in, and what is fair games for quizzes, is that you understand the underlying concept. And the underlying concept is that you want the level of measurement that provides the most accurate depiction of reality and that conveys the most information. Okay? Again, think about income. It's useful to know, all right, if I have an income variable with 5 categories, zero to $50,000, $50,000 to $100,000, and etc. That conveys some information, and we may want to use a variable like that for some things. But much easier and much more information conveyed, not much easier, but much more information conveyed and much more real information conveyed to say so-and-so made $51,372 last year. Now, later when we move to data analysis, we can always use interval data, raw number data, to go backwards and create ordinal measurements, right? Because we have the raw data, it's incredibly easy in a statistics program to create ordinal measures out of interval data, okay? And that's a valid thing to do during data analysis. But during the early stages of a project, the operationalization phase, the data collection phase, more information is always better. So strive for either interval measurement if it's something real that you can count, or ordinal measurement. All right. Measurement error is when something causes a change in your measure other than the central concept you care about. Again, think about the teacher evaluation answer. If I give out a teacher evaluation, it's because VCU wants you to know how they feel, or how to feel about, let me start again. If I give out a teacher evaluation, it's because the central concept that VCU cares about is your evaluation of me as a professor. If I give that evaluation out right after a pop quiz, it may catch your feelings towards me as a professor. It may also, but those feelings at that time might not be lasting because it may capture your feelings about the pop quiz instead, okay? Four potential causes of measurement error we discussed. One is the difference in distribution of other characteristics that our measure captures. Remember, a question about libertarianism, if we ask somebody if they're a libertarian or not, it may measure their belief about the Libertarian Party and their policy attitudes, but it may also capture their political knowledge, because you have to know a certain amount of political knowledge is necessary to know what a libertarian is. Number two, differences in temporary stuff that might affect answers. The pop quiz example is the prototypical thing. Also, it would have been a really bad idea to do a survey on airline safety on September 12th, 2001. Whatever our new feelings about airline safety were, the emotion was running too high that day. There would have been measurement error if what we were interested in was a accurate depiction of people's stable preferences. Three, differences in how people interpret the measuring instrument. So think of the taco coat example here, right? Unscramble the word. Depending on your background, you interpret that word scramble differently. We have to take account of that. Differences in setting during interviews or survey taking. Think about my professor in graduate school who had to be mindful of the race of her interviewer when she was doing a study on elderly black public opinion. Okay, how people may react to the interview subjects or the interviewer, and you need to make sure you take account of that. All right. To wrap up operationalization, let me talk a little bit about validity and reliability. Okay. Validity. Validity is how well our measures correspond to the concepts they're supposed to reflect. In other words, validity is how well we've done our operationalization, how well we've moved from concept to measure. I like the two qualifications Mannheim and Rich give. For a measure to be valid, it needs to be appropriate and complete. Appropriate means it's got to measure some aspect of the concept accurately. So if we want valid measures of quality education, we want something that captures some aspect of what a quality education would be. That would be appropriate. Okay? Complete is the second thing. So appropriate and complete. The completeness obviously means you need to capture every aspect of the construct. So we might think that one of the measures of a quality education is the ratio of student to teachers. If we're measuring quality of education, that one passes the first criteria, but not the second, right? So it is appropriate in that it measures some aspect of a quality education, but just by itself, the ratio of student to teachers is not a complete encapsulation of what we mean by quality education. All right. We want to make sure that I'm going to add a third thing here, which is that you want to avoid measurement error. So you want to avoid picking measures that capture things other than the concept themselves, so far as that you're able. All right. So that leads to a question of how do you check validity? How do you actually look at whether or not the variable that you have chosen is a valid measure of the concept you care about? They give, Mannheim and Rich that is, give a couple different ways in which you can check for validity. All right. I'm going to run through three of them here. Pragmatic or predictive validity. How well does a measure work in predicting future activities? So if we have a statistical model that predicts the results of an election, does it accurately predict the results of the next election? So in other words, you come up with a theory, you have measures for that theory, and then you use it for the next to see if you can predict how the next thing is going to go. All right. Second way you can check for validation is construct validation. Are the measures of our relationship consistent with our hypotheses? The third one, which is the one I like best, is face validity. Does it seem like a good measure of the central concept? Oftentimes, that's all you really need to do, right? So if I do the quality education example, you could see I was doing face validation. I was checking to see if it seems like a good measure when I introduced it. I said, yeah, student-teacher ratio is appropriate but not complete. We need other stuff. That's face validation. Oftentimes, that is good enough. Now, reliability. Reliability asks, how stable are our measures? Are our measures real values indicating some real concept, or are they anomalous? Because when you're putting together a study, right, you're sampling. It could be that you get a bad sample, even if you have a big enough sample and things like that. You could just get a sample that is not representative of the entire population. How do you check for reliability? The only way to check for reliability is to do it with a different sample. Okay? So if I'm interested in the number, if I want to do a study on how many people at VCU are Republicans, how many are Democrats, how many are independent, how many third party. I do my study, and I do a sample of 500 kids, 500 students. The only way for me to check the reliability of my results is to go back maybe a week later, a month later, whatever, and do it with another 500 people. Check it again. That's how you establish reliability. All right? Another thing that you can do early in the process to help look at reliability and validity, actually. At the beginning of your study, you'll often look at a couple of very basic indicators to see if your sample is representative and if your measures are reliable and valid. So I might look at, when I do my initial survey of VCU political opinion, I might look at how many people identify as Republican or Democrat and compare that to previous studies nationwide on college student public opinion. And that would let me know if I'm sort of in line. I'll use that example. Okay? Good. With that, we wrap operationalization and we move on to interviewing. And I am going to break this up so that it's easier to upload the files. So I'm stopping here, and please proceed to part 2.